Good afternoon friends and welcome to the EduSite Network. Our today's topic of discussion is development of GIS, that is Geographic Information Systems, and for this discussion we have thus in our studio Dr. Pankaj Kumar, Assistant Professor, Department of Geography, Delhi School of Economics, University of Delhi. His specialization includes remote sensing and GIS, and in his area of research he studies through remote sensing and GIS the Himalayan topography. And with this brief introduction, I would like to welcome sir to our EduSite studio. Thank you for coming, sir. And with this, I request you to begin our today's lecture.
Okay. Good afternoon, everyone. So, the today's topic of discussion is development of geographic information system. And this GIS, generally we used to say this GIS, development of GIS. So, geographic information system is basic, which has been developed. And now, in this presentation, we will focus on what is GIS, the history of GIS, definitions of GIS, and basic elements of GIS. So, with the help of this computerization, which has opened a vast new potential in the way we communicate, analyze our surroundings, and make decisions, data representing the real world can be stored and processed to that they can be presented later in a simplified forms to suit a specific needs. Many of our decisions today depend on the details of our surroundings and require information about specific places on the Earth's surface. Such information is called geographical because it helps us to distinguish one place from the another, and it helps us also to make certain decisions while analyzing the data and finding the results. So, the geographic information system, or sometimes we say it geographic information science, is an interdisciplinary field of knowledge comprising geography, digital cartography, computer science, mathematics, image processing, pattern recognition, digital photogrammetry, and remote sensing. In another sense, GIS is an information processing system. Whatever the information we take from our surroundings or we take from any on the Earth's surface or near Earth's surface, we try to analyze these things and we try to come out with certain results, and these results we use in our decision making process. So, GIS is an information processing system which is an embodiment of information pertaining to objects on, above, and under the Earth's surface. And why does it matter for teaching? Geographic information systems are fundamental tools for learning geography. They provide a means of inquiring into geography through mapping by extending and deepening the way that maps are used to explore geographical issues. GIS can re-emphasize the spatial dimension of geography. As we are all aware about this, that geography is what? Geography is basically the reading of the Earth's surface, a study of the Earth's surface. Whatever the phenomena is happening on the Earth's surface, we try to decipher them, we try to analyze them with the help of geography. So, a spatial component is very much important in geography, and GIS, Geographic Information System or Geographic Information Science, helps in analyzing these phenomena happening on the Earth's surface. In order to understand what is going on in our world, we study the process and phenomena that bring about geographical change. Geoinformatics and GIS. Sometimes it is some persons wants to know what is geoinformatics and how it is different from the GIS. So, the spatial data handling involves many disciplines, and they are grouped according to how they deal with a spatial information. Development of a spatial concept, means of capturing and processing spatial data, formal and theoretical foundation, applications and support. These are the characteristics of the discipline, and with the help of all these components, we club them and make a discipline which is known as geoinformatics. So, the discipline that deals with all aspects of a spatial data handling is called geoinformatics. It is defined as geoinformatics is the integration of different disciplines dealing with spatial information. Geoinformatics has also been described as the science and technology dealing with the structure and character of spatial information, its capture, its classification and qualification, its storage, processing, portrayal and dissemination, including the infrastructure necessary to secure optimal use of this information. Lorne and Thompson describes it as the fusion of idea from geosciences and geoinformatics. Now we will see what is GIS, what exactly Geographical Information System and science is. An information system is an organized set of procedures, human resources, material resources used to gather, store, process, communicate information needed by an individual or organization to manage its operational and governmental activity. So here we see some keywords like information system uses the procedures. Some of basically the GIS is a computer assisted technology where we use some software, and in the software we have the procedures to do some work or to do some activity. So, and human resources are very important because whatever the techniques and tools we are using is being developed by the human resources, and we analyze this, we use these tools and technique for the betterment of our society. So, human resources, skilled human resources is required, is essential part of this information system. Then material resources like various components of this computer assisted technology we club together and make a holistic GIS system. It used to gather, store, process and communicate information. So here whatever we are going to study, we try to analyze the phenomena happening on the earth surface, and for that we gather some data. We try to extract the data source may vary, census of data, census gives the data, some other individual research organization they provide their own data, and individual researcher also collect the data. So they collect the data, they store it and classify the data according to their need, and they process the data with the help of this GIS tool and technique, and output of the data, whatever the analysis has been performed on that, and whatever the map or the result we generate from this processing, we communicate it to the community which uses our result and try to come out with certain decisions which help the organization, government agencies and the research individuals to find out certain information, and on that basis to go for implementing the planning and policy and giving the suggestions regarding the problems or phenomena being faced by the community or the society. So almost everything happens somewhere, and in most cases knowing where something happened is critically important, and GIS helps in knowing this. So it helps in providing position of country boundary, location of hospitals, routing delivery vehicles, management of forest stands, allocation of funds for sea defenses. So these are few examples of the GIS, but GIS has become a very vast tool. It covers all the aspects of the human society nowadays, and nowadays from starting even from the managing of a simple affairs of an individual to even a government organization. So it has endless scope of GIS technology nowadays. So geographical information systems are a special class of information system that keep track not only of events, activities and things, but also of where these events, activity and things happen or exist. Geographic location is an important attribute of activities, policies, strategy and plans. Geographic problems involve an aspect of location either in the information used to solve them or in the solutions themselves. So here three things are very important. One thing, when we talk about the geographic information, these information should have some locational attributes. So in GIS, we analyze these locational attributes like what is where and how it is there, what are the pattern we try to find out, and with this pattern and analysis of the data we try to solve these geographic problems. So GIS is in a simple way we say that it's a geographic reference plus information system. Whatever the data we have, whatever the data we put into GIS, Geographic Information System, it should be in a geographic coordinate system. So data of a spatial coordinates on the surface of the earth covers the geographic reference plus information system or database of attributes data corresponding to a spatial location and procedures to provide information for decision making. So GIS is information system with geographically different data. Without geographic reference data, there is no concept of GIS, because whatever the when you will go for georeferencing, then the exact coordinate system we provide to our components and which will be helpful in analyzing the area, width, depth and any other attributes related with that object with the help of this georeferencing technique. So in GIS we have the real world situation, we get the data from this real world situation and we input the data with the help of some hardware techniques and some input devices available, and input data we try to analyze or classify this data. We try to sorting out of this data according to our needs, and then we analyze and do operation on that data to give them the value. And this value make them possible to utilize by ourselves, and the users and the interpreters take decision on the basis of these processed and analyzed data. So there are 5 basic questions which a complete GIS must answer, and these are: what exists at a particular location given a geographic reference, as for example latitude and longitude for a location. The GIS must describe the feature of the location. Where can a specific feature be found? So we try to build a query, and it's very easy to build query in GIS. Like if we have the rainfall of all over the India and we have put the data into this GIS domain, we can easily extract the information by query building, just like that you give me the rainfall greater than 500 millimeter, and the map it will automatically generate, which will circle the area where this type of 500 millimeter of rainfall is occurring. So we try to build query. And another thing, trend or what has happened over time. So to find out the change detection or monitoring of something in temporal framework, GIS is very important. Suppose we have to see a change in the land use, land cover, and so we try to analyze 2-3 time framework data, and with this data we can give a trend, picture of trend, how the land use pattern is shifting and where we are. We can also go for analyzing the trend of rainfall pattern. We can go for analyzing the trend of any other aspects with the help of remote sensing data, which is now readily available in India and in the global area also. So what a spatial pattern exists? If occurrence of a pest is associated with a hypothesized set of condition of temperature, precipitation, humidity, where do those conditions exist? So we try to find out the spatial pattern, like where the forest is degraded, where the forest is more in a good healthy condition. So we try with the help of this GIS and with the help of this query building, we try to find out the spatial pattern, and then we also do the modeling or what if. Modeling is now becoming a very prominent field in the GIS, and the software developers are coming with the tools which help in modeling our phenomena, or we help in modeling our any type of like land use, land cover change. We can model it for the future, finding out the future direction. We can model our rainfall pattern, we can model our temperature scenario. So modeling is this is a higher level application of GIS, and it answers question like what would be suppose in the case of nitrate distribution in groundwater over the area if fertilizer use is double. So likewise we can set a criteria, and with the help of that we can model the scenario. We can even model if fertilizer is becoming double or tripled, or if there is no use of fertilizer in the cropping field. So what will be the scenario, or what will be the production? We can analyze, or we can model, or we can future forecast with the help of this GIS technique. So a working definition of GIS, generally RIND and United States of Geological Survey provide a simple working definition of GIS. They says, RIND says, a system of hardware, software and procedures designed to support the capture, management, manipulation, analysis, modeling and display of a spatially referenced data for solving complex planning and management problems. So it is a system which is a clubbing of various components, like there is a hardware, computer and all other accessories, then there is a software developed by the GIS experts, and the procedures designed to support and capture and management whatever the data we take, we capture from the remote sensing or other sources or Census of India and all, we put into the GIS environment, and then we try to manage them, manipulate them. If there is any error, we try to minimize them, then analyze the data, we model the data and display the data, and all these data are geo-reference, having exact latitude, longitude, position for, and then data for solving complex planning and management problems. So it is also according to United States Geological Survey 1997, it is a computer system capable of assembling, storing, manipulating and displaying geographically referenced information, that is data identified according to their location. Since the mid 1970s, a specialized computer system have been developed to process geographical information in various ways. These include some of the techniques like technique to input geographical information, converting the information to digital form, technique for sorting, storing such information in compact format or computer disk, compact disk and other digital storage media, methods for automated analysis of geographical data to search for patterns, combine different kinds of data, make measurements, find optimum sites or routes and a host of other tasks. Methods to predict the outcome of various scenarios such as the effect of climate change on vegetation, techniques for display of data in the form of maps, images and other kinds of display. So altogether the development or whatever the technological development has taken place in all these techniques, in a storage capacity, in converting the information in digital form, automated analysis of geographical data, methods to predict the outcome of various scenarios, so modeling aspects and displaying a map in a good manner, images. So all these components and their development is attached with the development of the GIS. The collective name for such system is Geographical Information System, and the term Geographical Information System is now used genetically for any computer based capability for the manipulation of geographical data. A GIS includes not only hardware and software but also the spatial devices used to input maps and to create map products together with the communication system needed to link various elements. Thus, GIS is a very big computer system where we have the computer and associated accessories for inputting the data, manipulating the data. Then we have the software component, then we have the analysis and all, and we have the hardware, software, and people are also important here, and the map products. So altogether development of technology related with these aspects has helped much in development of this geographic information system. If we will see the history of GIS, geographic information system is a relatively new branch of information technology. The term GIS did not appear until the early 1960s when the Canada Geographic Information System was developed. During this short span of history, both the technology used to construct GIS and the function of GIS have undergone considerable changes. So GIS as we understand it today is very different from its predecessors. Three distinct phases we notice when we see the history. The first phase is the pioneers phase, which is known as the formative years in the 1960s and 70s. The second phase is the breakthrough phase, maturing technology from the early 1980s to mid 1990s. Third phase is the age of geographic information infrastructure, started from mid 1990s. So the pioneer phase, where the initiation of this technology started, is in 1960s, and from there the development of this GIS has taken place. But the maturing or the main framework development of this GIS and when it came into the public domain is from early 1980s to the mid 1990s, and now it has started the age of geographic information infrastructure, which is from 1990s onward. So we see here three distinct phases, and we see in next this slides we are going to see the details of each and every phase. Here we notice that the theme framework for the development of GIS, 1960-1980s, the technical environment, in front of technical environment, in front of major users, and in front of major application areas, we notice distinct phases and distinct characteristics of each phase. So in 1960s, 1980s, the mainframe computers were the basic components of the GIS. Proprietary softwares were developed, proprietary data structure, mainly raster based data, and government and university and military were the major users of this technology in 1960-1980s when the formative age was there. And the basic thrust area of this GIS technology in this time was the land and resource management, the census operation, and the surveying and mapping of the resources. But in 1980s, 1990s, the focus drastically changed, and the technological advancement in this field provide us an opportunity to not only concentrate on mainframe and mini computers, but now we are moving towards the mini computers and geo-relational data structure, where we can store the raster and vector data together. Then geographical user interface, like whatever our requirement is there, we can synchronize this software according to our need. New data acquisition technology, GPS, redemption of data, and remote sensing. So we see technological environment from development in 1980s and 1990s. Major users added here are the utilities and the business persons. So the big business houses started, apart from government, university, and military, the big business houses and the utility sectors started using this technology in their areas. And the major application areas where the two things added here is the facility management and the market analysis. And mid 1990s and onwards, we see a drastic change in the technological front, major user front, and the major application front. So GIS, from a traditional approach to now modern approach, we can see that in a traditional approach it was very limited. The reach of this technology was only limited to the government, university and military people, but now it has become open to the in the public domain, and now a general public can use this technology for taking decisions, for analyzing their data and finding out some solution of their problem. So workstation and PCs, network, internet, open system design, multimedia, data integration, enterprise computing, object relational data models were the advancement in the technological front, while major user front, the general public, utilities, business and other organization came in, research organization started using these things. Major application area, we now see that the it's not only limited to the land and resource management, but now it is being used by the facility management and market analysis by big companies or big these corporate houses. They take this GIS technique for decision making and support. The pioneers phase, the formative years in the 1960s and 1970s, as a computer dependent application, the origin of GIS could be traced to research and development in electronic data processing back to 1940s and 1950s. The graphical data processing at the Massachusetts Institute of Technology in 1955 and database management system by General Electric in 1965 did some work in the field of this GIS development. So in the 1970s, developments mainly took place at university in the United States, in Canada and the United Kingdom. The Laboratory for Computer Graphics and Spatial Analysis of the Harvard Graduate School of Design or the Geographic Information System Laboratory at Sunny Buffalo achieved a worldwide recognition, and commercial agencies started to develop and offer GIS software. So we see that in 1970, approaching 1970, there was now commercialization of this. So the broadening or opening of the GIS technology into public domain. A growing awareness of the need for sound and stable structure to store and analyze map data became dominant in the late 1970s, because at that time the society became more complex, and with this complex society and with the help of new technology available in the market, there was a huge generation of the data. So if there is a data available in the society, then definitely for decision purposes we try to analyze this data in a faster manner, and that's why the GIS it developed very fast in 1970s and onward. So the landmark paper by James Corbett on topological principle in cartography became a milestone in research on a spatial relationship. Here I want to mention that this topological principle in cartography was one of the landmark which provided us opportunity to integrate raster and the vector both together, and we can store our data in a more simplified manner than the earlier. So we can store our data, the raster and the vector, in a relational manner. So this topological development or this topological principle in cartography become a very important development in the field of research and development of this GIS. So CGIS, Canada GIS, was conceptualized in 1960 and become operational in 1971 for land and resource information management in Canada. In 1973, the USGS started the development of Geographical Information Retrieval and Analysis System to handle and analyze land use and land cover data. At the same time, Swedish Land Data Bank were also established to digitize their land cover and land use system. Then Local Authority Management Information System and Joint Information System was developed by Britain to manage their local resources. So the growing interest in computer-based map data processing also initiated several active research and development programs in universities in Europe and North America. The pioneers were the Harvard Laboratory of Computer Graphics, where first contemporary vector GIS called ODESSY was developed. the Center for Regional and Urban Analysis, University of Minnesota, Experimental Cartographic Unit at the Royal College of Art in London, Geographic Information Mapping and Management System at Department of Geography, University of Edinburgh. They were the pioneer in the field of the development of GIS in its basic initial stage or initial age, first phase. So, the major points of this phase were this technique was used and developed mainly by the government agencies and universities, and the software running in batch mode as a standalone software application. For performing the GIS task, we have several components, like we have to collect the data and we have to store the data, we have to retrieve and manipulate the data, we have to analyze the data, and then we have to come out with the result in the form of maps and figures. But earlier all these performance or all these tasks were being performed by different software. So, the software running in a batch mode and a standalone software application. Proprietary software programs and data structure means the GIS software were developed by some organization for their specific usage. No other person cannot access that because they have the proprietary of that software and the data structure. So, more work on raster cells, because in this phase there was no topological development in the field of GIS. So, the GIS mainly concentrated on the satellite pictures or the aerial photographs which we generally take from our satellites and the planes and all. And then the focus was mainly on the rasterization or the raster cells, and we try to analyze the things with the help of this data or the provided by the satellites and all. Resource management was the primary areas, because at that time there was a problem of depleting of resources. So, resource management was the primary focus. Use remained more in defense, utilities, transportation, population sensors, surveying and mapping, as I have already explained these things. Map data processing was the primary focus. So, sometime it is said that the GIS is only a map making, because the focus of this initial phase was to produce map digitally. So, we tried to say that the map making is the only focus of this GIS in this initial phase. A specific information needs of individual organization. Whatever the softwares were developed and whatever the GIS technology was developed at that time, it was only in the domain of individual organization. So, this type of situation remained prevalent in the first phase, which is known as the pioneer phase. Now, there is the breakthrough or maturing technology from early 1980s to mid 1990s. The technical paper of Corbett on the concept of topology as applied to spatial data was a major milestone in the development of GIS concept and technology. Using the concept of topology, geographic data can be stored in simple structure that is capable of representing their attributes, that is what they are, where they are, as well as their relationship. Earlier we used to store the data separately, separate data, raster data, separate attributes data, and if we have to separate vector data, and if we have to attach the attributes of this vector data, it was difficult. But with the help of this development of this topology, now we can store and we can manage our data, GIS data, the vast data, in a very simple and in a very nice manner. So, in 1982, Environmental System Research Institute ISRI released ArcInfo based on mini computer, and that was a revolutionary thing in the development of the GIS, because with the help of this mini computer, now this technology is reaching to even a simple person, and a simple person can purchase the software, can handle this GIS by having a limited or a minimum training to these softwares, how to handle the data and how to analyze this thing. So, InfoMap by Synchroncom, United States, carries by Universal System Limited, Canada, Map Info, Spans and PC Arc Info were some of the software developed during this phase. The focus of GIS in this phase was to handle the methods of data collection, quality and standard, as well as data analysis and data organization. So, earlier phase was basically focusing on the handling of making of the map, producing of the map with the help of the data. So, the focus was mainly to the map production, but now in the this second phase the focus shifted to the method of data collection, how to collect the data and how to maintain the quality and standard of data in a better manner, how we can minimize the errors being prevalent in the data if we take the data from some other organization or in the remote sensing and GIS. So, the method, so the approach is shifting, and the earlier approach was to make the map more and more, digitize the map and all, but now the focus is of better data collection technique and quality and standard maintenance. So, data oriented approach of GIS development fundamentally changed the way GIS technology had been developed. It led to the integration of raster and vector geographic data. The application of GIS were no longer limited to the traditional area of land and resource management, but quickly extended to new areas that included facility management, vehicle navigation, market research and decision support in business management. So, see here the transformation, the earlier application was limited only to the military, in the hand of military, in the hand of certain universities or in the hand of the government organization. This technology was not open to the public sectors things, but now this technology is in the hand of public sectors, and this public sectors organization and these multinational companies and even the individual researchers are now taking the decision about their problems, about their phenomena, about their business management with the help of this GIS data and data handling and management technique. The age of geographic information infrastructure started in the mid 1990s. The concept of information infrastructure emerged in early 1990s. The objective of this initiative was to provide all citizens access to information affecting their lives that pertain to government, healthcare, education and community development. So, the last phase, which started in mid 1990s, is focusing on the information infrastructure, how to build up a big infrastructure of information which can be will be accessed by everyone. So, the word infrastructure here implies that geographic information must be treated in the same way as other economic and political infrastructure in the society, such as highway and bridges, power and communication network and etc. So, now the focus of the government organization and the public or the society is to build the GIS to such a level that it can be equal to the all political and economic infrastructure of the society. So, need of this GIS has been visualized in this phase, and now we see the result. The concept of geographic information infrastructure can be applied globally also, where international and regional organizations are formed to deal with the geographic information issues that transcend national boundaries, such as international navigation, air and maritime transportation, weather forecasting, natural hazards and global change. And nowadays we see this type of data management centers are there in certain in the developed countries and even the developing countries, and they disseminate the information prior to the happening of certain disasters like the cyclone or any type of tsunami. They give the information or they share the information to nearby countries for better management or better rehabilitation and mitigation measures. So, a typical GIS today has the following technical and operational characteristics. It is a part of computer network rather than a standalone computer. it is made up of multi-tier distributed software components, so multitasking is possible now. It is connected to the internet for access to data and technical resources available on the World Wide Web and for distributing to geographic information. It uses data stored locally in its own hard drives and data drawn from local server through local area network, as well as data obtained from national, regional and corporate data warehouses through intranet. Because of this help of this World Wide Web, we disseminate the information easily to the required person, to the person who takes the decision with the help of this data. So the fast movement of the data from both sides, the input and output, is because of this World Wide Web and internet facility. It is capable of using raster and vector data, and it can integrate geographic data with other forms of business data in a totally integrated manner. It is capable of representing the result of information retrieval and analysis using multimedia technology that includes sound, graphic and animation. So nowadays we can synchronize this technology or software according to our need. We can club other technology, other software which is helpful in animation. So animation things we can incorporate in this GIS technology. Nowadays there is a tendency of developing this software which uses both the components, the remote sensing and the GIS. So they are trying to provide a platform where a single user can do multitask by integrating this type of software, and so it will minimize the cost, and so we don't need different software to perform different tasks of GIS. Then definitions of GIS. GIS definition has been clubbed into three categories. The definition based on concept of database. Three definitions I have chosen here. A database system in which most of the data are spatially indexed and upon which a set of procedures operated in order to answer queries about spatial entities in the database. Smith T.R. et al. 1987. Any manual or computer based set of procedures used to store and manipulate geographically referenced data. Arnoff 1989. And information technology which stores, analyzes and displays both spatial and non-spatial data. Parker 1988. So the proponents of the GIS technology, those who focus more on the data, how to manage the data, how to analyze the data, how to store the data in a better way, they have focused more on the management and this manipulation of the data, storing of data in their GIS definition. So if you see the first definition, he says that the database system in which most of the data are spatially indexed and upon which a set of procedure operated in order to answer queries about a spatial entity in the database. So Arnoff also says that manipulate geographically referenced data. Parker said that how to analyze and display and store both spatial and non-spatial data. So they are focusing more on the data aspect. That's why they have been clubbed into the concept of database definition. Then definition based on instrument and technology. The proponent of this philosophy, they say that the GIS is a powerful set of tools for collecting, storing, retrieving at will, transforming and displaying spatial data from the real world. Burrow, McDowell, A. 1998. A system for capturing, storing, checking, manipulating, analyzing and displaying data which are spatially referenced to the Earth. Department of Environment, London, 1987. An automated set of functions that provides professionals with advanced capabilities for storage, retrieval, manipulation and display of geographically referenced data. So they are focusing more on the technological aspect, like how to manage this data, how to restore this data in a better way to retrieve the information or to work upon that. Definition based on organizational aspects. So Cohen, DJ 1988 says that a decision support system involving the integration of spatially referenced data in a problem solving environment. A form of MIS, management information system. So GIS is a management information system, how we can manage our affairs in a nice manner. That allows map display of general information, where the maps are used for taking the decision or managing our affairs. So the United States Geological Survey defines GIS as a computer hardware and software system designed to collect, manage, analyze and display geographically spatially referenced data. So spatial reference is everywhere. Without this spatial reference, without the geographical reference, there is no GIS. Cohen suggests that there are 4 different ways or approaches of separating GIS from other information system. These are the process or function oriented, application, toolbox and database approaches. So 3 approaches we have earlier talked, we have already talked, on the basis of which we clubbed their definitions. All the definitions, however, have a single common features, that GIS are system which deals with the geographical information. There are 3 views of GIS. The various idea about GIS can be synthesized and presented in the form of 3 distinct but overlapping views. These can be termed as map view, database view and a spatial analysis view. The map view focus on the cartographic aspect of GIS. They says that the GIS is to work as a cartographic, digital cartography. So they equate GIS with digital cartography, map making, digitization and map making production. So this view was promoted by McHarg, Berry and Tomlin. Supporters of this view see GIS as map processing or displaying system. Each data set is represented as a map. So whatever the input we are putting in this GIS domain, we have to get the output in a map form. Then it will be a GIS as per the view of this map view supporters. The map are usually, the map view also says the map are usually held in raster format and are manipulated by function that might add, subtract or search for pattern. The output from these operations is another map. The Topographic and thematic mapping agency also support this view. Next view is the database view of GIS, emphasizes the importance of a well-designed and implemented database. A sophisticated database management system is seen as an integral part of the GIS. Personal geodatabase, relational geodatabase are the example. So as I have earlier talked in the definition part, the database view are also supporting this, like how to manage our big data, because data is now available and we have various sources from where we can collect the data. So this enormous amount of data is a problem for a researcher. How to manage this data, how to restore, how to classify this data. So that's why this database management view or this database view emphasizes that GIS is basically the geodatabase management system. Then the spatial analysis view focuses on analysis and modeling, in which GIS is seen more as a spatial information science than a technology. It is most widely accepted by GIS community. So some of the expert or some of the proponent of this GIS says that GIS is a spatial analysis tool, which is not only the tool but it is a science. When it becomes the science, GIS generally try to get the information and try to analyze the information and give the result in the form of the map. But if it is limited to these aspects only, then it is geographic information system. But when we use these maps and the map for decision making or for welfare of the society or taking the output of this for making some decisions, then it becomes the science. So these views, a spatial analysis view says that we are more supporting they support the view that it is not only the system but it is a science where we use and we model our scenario or we future forecast for a spatial phenomena. Then data, information and knowledge. Whatever we have talked here, one thing is common everywhere is the data. And what is the data? In almost all definition of GIS quoted above, the word data has been used. When the word data is used, it usually refers to a collection of facts or figures that pertain to places, people, things, events and concepts. So, whatever there is input in this GIS domain in this tool, GIS tool, is the data, but this data is of no use, because they are in an array of information like population census data, like any other household census data. So, we try to sort out this data according to our need. So, when these facts and figures generally represented and generally these data are represented in numerical values, alphanumerical characters, symbols and signals. So, when this data is transformed through processes such as structuring, formatting, conversion and modeling to a form that is meaningful to a user, it is referred to as a information. So, when we add some value to this data, then it becomes the information, and information therefore is a processed or value added data that have certain perceived value to a user or a community of user. The transformation of data into useful information is the core function of this information system. So, the transformation of data into information is an explicit act by a user to raise their or his or her knowledge to a level appropriate for a specific decision making process. When the user deploys this knowledge to perceive relationship, formulate principles and introduce personal value and belief, he and she develops what is called intelligence or wisdom. So, data helps in development of information, information helps in making the decision, so enriching the knowledge, and this knowledge is helpful in providing the intelligence and wisdom on which we take the decision for our society. So, intelligence enriches our life, and the collective intelligence of humankind drives the evolution of civilization. Then another aspect of this GIS is the elements of GIS. A geographic information system is a system of computer software, hardware and data, and the personnel that make it possible to enter, manipulate, analyze and present information that is tied to a location on the earth's surface. So, there are 5 components or 5 elements of GIS. First is the people, data, software, hardware and procedure. All together make this GIS. So, first coming to this people. People are the most important part of a GIS because they define and develop the procedures used by the GIS. Whatever the technique and whatever the procedures we are using in this GIS technique is being developed by the people itself. How to collect the data, how to sort out, how to check the cross-check the data, how to go for the ground truthing or data collection, or all these type of information we do or we perform this type of task only with the help of the people. So, people are one of the integral part of this GIS. It can overcome shortcomings of other 4 elements like data, hardware, software, procedures. Okay, and data storing, processing and analysis is also being done by the people. So, human resource or the people is most important part of the GIS who developed this GIS for their betterment and who try to always enrich or reinforce with new ideas and new technology in this present form of GIS technology. The second is the data. Data is the information used within a GIS. Since a GIS often incorporates data from multiple sources, its accuracy defines the quality of GIS. So, which type of data are you going to use? Even in the remote sensing data, there are some coarse resolution data and there are some high resolution data. So, in topographic mapping, in this cadastral mapping or any type of mapping, we used to convert the real ground picture into the digital form in this GIS. So, the quality aspects remain very important when we take the data. So, GIS quality determines the type of questions and problems that may be asked of the GIS. So, we have now the latest technology of GPS, and with the help of this GPS now we are more to get information, we can get more information and we can cross check our information or we can perform the ground truthing task. Then GIS software is another component of this technology. It encompasses not only to the GIS package, but all the software used for databases, drawings, statistics and imaging. The functionality of the software used to manage the GIS determines the types of problem that the GIS may be used to solve. The software used must match the needs and skill of the end user. So according to the needs and skill of the end users, now the GIS companies are modifying their software and giving into the public domain. Now they are also coming out with the open GIS software like Quantum GIS, which has been developed by the ISRI, and it is free for public to use. The popular GIS software are the vector-based GIS is ArcGIS, has been developed by ISRI, ArcView, ArcMapInfo. Raster-based GIS are ADAS Imagine, INVI, ILVIS and ODESSY. Then there is a hardware. The type of hardware determines to an extent the speed at which a GIS will operate. So hardware helps in inputting the data into this GIS domain. So quality of hardware also determines the quality and the approach how to proceed for inputting the data. So additionally, it may influence the type of software used. To a small degree, it may influence the types, personalities of the people working with the GIS. If you have a good hardware, then the data processing or inputting become fast. So the hardware component is very important. Then it's a procedures and the method. The procedure used to input, analyze and query data determines the quality and validity of the final product. So procedures, which procedure is important for which type of working. If we have to go for water resource management, natural resource management, then if we have to go for analyzing the glaciers environment. So there are different type of procedures implied for different type of working. So with the help of this, the procedures used are simple, the steps taken in well-defined and consistent method to produce correct and reproducible results from the GIS system. So first step in this, that state the problem. Second step, break the problem down and find out what are the characteristics to reach your goals, objectives to reach your goals. What are the phenomena and interactions necessary to model, and what will be the end result. So this type of the break the problem down. Then third step is explore input database. Fourth step is to perform analysis, and the fifth stage is to verify and model the result. If there is any problems, then again go to the fourth step, perform analysis, and then sixth step is to implement the result. So with this I am going to end my discussion. Thank you.
Thank you so much, sir, for the very interesting presentation. In fact, we could also see a flow chart that you had made at the ends in order to conceptualize the steps. And so we don't have much time left, but very briefly, could you suggest the name of any books that one could read on this topic?
Yeah, GIS, lots of materials are there on the website also, and we have books in the library. Leon, this Cheng, one book is written by this very lots of material of Berkeley Institute. Basically they provide the material on the website, and from there they can download and read the books.
Right.
So,
right.
And one book by Prithvish Nag is there, and generally the library have this book. So
all right,
they can prefer this book.
Right. Thank you so much, sir. And with this, we would like to bring our lecture to a close. And thanks, sir, for being here. Sincerely, thank you, sir. And it's very kind of you to spare your valuable time and come here to our network and deliver a lecture. Thank you for that again, sir. And thank you viewers for watching. Have a wonderful day ahead.